All right, so the first thing I need to figure out here is what the formula is for the conjugate acid that would pair with each of these substances. Now remember, conjugates are only going to differ by a single H+. So whenever you hear the word conjugate, the thing you're looking for is either going to be missing an H+ or have an extra H+ compared to the thing you already have. Now, since we're looking for a conjugate acid, that means that these guys are already bases. And what do bases do? They accept H pluses or protons. So when I say conjugate acids, I'm looking for the versions of these that have one more H plus. Now, NH3, well, if you add an H to him, he becomes NH4. But don't forget that you're also adding a plus. Since he didn't have a charge originally, he's now going to have a positive charge. I can do the same thing with H2O, and that turns it into H3O. And since he did not have a charge, he's also going to be positively charged. Now CO3 2- carbonate is going to become HCO3. Now he was a 2-. Picking up an H is going to get rid of one of those negatives or cancel it out. So he's just going to go back to being a 1-. And then the F- here is going to become HF. And the 1+ from the H is going to cancel out the 1- that's already here. Now, the final part of this is determining the strength of each substance. Now remember, substances that are weak are still going to be weak when they're conjugates. So NH4+ is going to be weak. This guy's not entirely sure he wants to be a base, which means this guy's not entirely sure he wants to be an acid. Now H2O is completely neutral, which means that when he becomes an acid, he's going to be very strong. This guy's, you can kind of think of him as being not inclined to be a base at all, which means he's really going to want to give that H away. And then the CO3 2- here, he was weak, which means his conjugate will still be weak. And the F-, because he was weak, his conjugate will also be weak. All right, and that's it.